welcome back to the channel. For those of you that haven't been on the channel before, my name's Emma. I run EES Fabrication. Please look us up online. And if you're enjoying the content, please hit like and subscribe because it really helps the channel out. So, what are we building today? So today we're going to be building a bale spike for a 5.5 ton Kubota digger. So this is sort of the main kind of work we do as a company. It's agricultural work, and we also do work for the domestic sector, which would be garden gates, railings, balconies, the odd staircase, bits and pieces like that. But 90% of our work is agricultural based or large plant based, so diggers, excavators, bulldozers and such like. So today we're building this bale spike, like I said. So at the moment we're doing a few little quick sketch drawings, 5 packet drawings I like to call them, although I don't smoke, but quick 5 packet drawing to get a few dimensions before we hit the computer and get these drawings turned into an actual physical drawing, which we can then put into the another computer, which will run our CNC plasma cutter. So I'll get the camera, we'll turn it round and we'll go through what the drawing is currently, and then we'll head our way over to the computer and start doing the designing. So this is how a lot of our drawings start. It's with me with a pen and some very, very quick, awful drawings. I didn't win any competitions in art, put it that way. So this is going to be our ear for our pin layout. So we've got 180mm centre to centre on the pins. We've got 150 box, which I've already cut here, which is going to go across the front to hold the collars for the tines. The length of the box is 12-18. The size of the collar is 45mm. And the size of the pins from memory, write that on there now, is 40mm. I'll just go and check that on our way past the bucket that we've been supplied by the customer. Just check that that's correct. But it's either 40 or 45, but I'm pretty sure that this one is a 40. However, I've done another digger this week, which was on 45s, which we've gone down to 40s. So I just want to check whether my memory serves me correct on that one. So that is what we start off with. Hi all, welcome to the drawing stage. So we're now sat in front of the computer, as you can see. If you hear some funny little noises in the background that you can't quite work out what they are, it's me trying to balance family time and work time. So I'm actually currently sat in my front room and I've got my little newborn baby behind me that I'm trying to tend to at the same time as doing this video. Unfortunately, running a one-man workshop, this is quite often the case of an evening. I try and do all our drawings once it goes dark, primarily so we can keep as much daytime hours outside working. So basically, if you hear any funny little noises that you can't work out what it is, it's not me acting like a child. We have actually got a child here. So we open the drawing plane up, and I'm going to try and go through this in detail, but as quickly as possible. So first of all, this is the way I draw it. There's many ways to draw a drawing like this, and I do not profess to be the best CAD drawer of all time, and I'm never going to be either. So we said it's 180mm between centres. So this line now represents our between centre values, and our pin holes. We need 40mm pins, but I don't want them to be overly too tight when we're building it, so we're going to make them 42mm OD. We now need another circle on the other end of that line, which we put on there. And what we'll do then is we say for that line and that line both to be equal. So if we come back to the drawing and we change this dimension, this one will automatically change. Try and do that as much as possible in drawings. It does take a little bit longer to do it. However, if you future-proofing it, if you want to come back to change something, it's much easier if you've done it in the beginning than chasing around, especially if you've got like 30, 40 holes in a drawing and they're all meant to be the same size. And you go to cut it, and then you find out that actually the hole that you've asked it to be 12mm is better to be 14mm. It's much easier just to change one dimension and it changes them automatically than it is to go through each one individually and change it. So at this moment in time, we are doing things almost by eye. There is no exact setup for the numbers here currently. We just need to get some sort of drawing drawn so we can see what we're playing with. Obviously, there are a few rules of thumbs along the way. You know, the distance, but these now are going to be the outer circles for this ear. So the distance between here and here, I like to have about 20mm there. So what have we got? 40 up to, yeah, we could go up a little bit bigger on those actually. So let's go, take them up to 70, 80. And what I will actually do here is take the liberty of taking that dimension out and doing what I said 5 minutes ago, that those two. Hang on, we've got a computer that doesn't understand what I'm asking it, or a person that doesn't know how to drive it. It's probably the latter. Those two circles there need to be equal. Right. Now we want to put a 3-point arc between the top section. And we need to actually tell that line where it's got to be on the drawing. When drawing dimensions turn black, that means that they're fully defined and the computer understands the geometry where it is. Until they turn black, that line could actually be moved. So yes, I told it the point there is 30mm and the point there was 30mm, but I hadn't actually told it the radius of that curve. So it could be that it joins on that sort of angle, or it could have been joining that sort of angle. So now we've got those in place, let's head over and draw in our 100 by 50 box. However, it's not going to be a 150 box on the drawing because, one, we need a bit of clearance to get it physically in when we're welding it. If you made it bang on 50mm and bang on 100, you'd struggle to get it in. And also there's a radius on the box, which I'll show you later when we're back out in the workshop. And if we made it 50mm, it'd actually overhang the radius of the box, which looks unsightly. So the drawing we're going to put on here, we're going to put 45mm in, because we've got a 5mm radius on this box from memory. And we're going to be a little bit bigger than 100 because we want a little bit of clearance. So we'll make it 102. 102 will still be tight because we're going to have a slight kerf on this. And the kerf, when you're talking plasma cutting, what we mean by kerf is because you've got a flame that's cutting in a V formation, basically, from a plasma cutter, you never get a perfectly 90-degree cut. It's always a slightly beveled cut. So depending on which way that bevel is going, it can sometimes tighten up your tolerances. So hence why we build in that tolerance of the 2mm. So, like I say, rule of thumb, I want at least 30mm of material top and bottom of this box way through to the back of this box section. We can weld the box to it as well and get add an extra little bit of strength there. And from here to here is going to fall at a dimension that I haven't thought of yet. there we are. So that's the car. So welcome back. We're now back in the workshop. As you'll have noticed, I've gone back in and altered this drawing slightly because I realised afterwards the drawing that I'd already drawn was so tight with the pin. When it was on fully crowd, it would potentially come and touch the ram. So I've decided to make it a little bit longer. So yeah, so basically I've inputted them into our plasma cutter. Our plasma cutter is a Xtream plasma that we have butchered, basically. We cut up an Xtream plasma cutter, used the driving software for it, but the actual hardware, the actual table, we created our own because we wanted something a little bit bigger than what they offered. Well, they do offer a 10x5 table, but they didn't offer it in the timescale that we wanted at the time because they were so busy. So we basically bought a 4x4 table, cannibalized it, and made our own. So, but to be fair to it, absolutely faultless up until now. Really, really pleased with it. So I just inputted the size of material we've got at hand because it's an offcut. Made sure that these fit on the offcut tidily, which they do, with plenty of room to spare. I've told it the thickness of the material. I've asked it to create the cutting paths, which you can see as a green line here. The green line is what it's going to be cutting. The blue line is the path in which it's taking. So it's going to cut that one first, then it's going to cut this slot, then it's those two circles, then it's the outer one of those, and then it's the same on the top one again. So I've asked it to create that as a drawing file, so as a G-code, sorry. And now we're going to open up Mach 3. Mach 3 is a driver for many CNC applications. You can use it for lathes and milling machines as well. I've never done so, but it is possible. I think they've actually changed the driving software for it on the Xtream Plasma now. Supposedly this was a little bit difficult to use, although I found it easy enough once I got my head around it. So in the background now, you should be able to hear the machine moving. So we'll bring it down onto the plate, and then we can set our 0 values, and we can go from there. So welcome back. We didn't manage to quite finish this last night. Family commitments came in the way in the form of a screaming baby. And Gemma was out and I had to go and tend to him. So we're back in the workshop today, and I'll spin the camera around and we'll show you where we got to, and then we'll start welding up. So this is how far we got last night. Managed to tack weld one side in. We just linished the sides of these off on the belt sander, just so they're not such a sharp edge. 90 degree in there gives us a rough guide of where we're going to be. Just need to do the final fit up now. Fire up the welder, tack this side in, tack it all up, check the measurements, and then we'll fully weld it. So I'll put the camera on the one side and we'll get on with that. So today I'm going to weld this up with the Campy welder. Going to fire that up. This is one that we bought in a job lot of other machinery. Really good welder, ex-factory. It's about 350 odd amp. So it'll buzz through 12mm plate, no problems. So fire the generator up and then we'll start welding this up. Just checking the measurements here. And there we have it. Ready to go out to the customer. And hopefully you'll try and deliver that this evening.